the trough area and get a couple samples from there. We want to save one of the ovens for analyzing our organic-free blank. In the event that we're fortunate enough to detect organic molecules, we've got a material we brought along with us which is designed to be free of organic molecules. And one of the things we want to do, of course, is if we detect organic molecules in the Mars sample, we want to be able to say with some confidence that it's not just contamination we brought with us. We built the TIGA instrument and the robotic arm under very, very clean conditions, but you can never tell for sure that you don't have some very modest amount of contamination. So we are going to reserve the one of the TIGA cells as a blank to make sure that we understand how much organic contamination we might be bringing from Earth and how much could be coming from Mars.
Mark, go ahead with your follow-up.
Thank you. I think I did count in your assessment still 6 ovens, and I'm wondering at this point if that's correct, do you still have a good shot, do you think, at trying to find organics if they're there before the extended mission ends? And I'm also wondering, is part of the reason for extending the mission to give you a chance to do that since you're 2 months into the project?
I think we'll actually be able to do as good a test as we can looking for organic molecules, I think, before the mission comes to an end. We're learning as we go along the best way to heat the soil and the different properties that we are finding, and we have ways of fine-tuning the instrument to make it more sensitive for organic molecules at the expense of other molecules. Now, the reason for getting the extended mission is not just so that TIGA could fill out and analyze the remaining ovens that we have, but for many other reasons that Peter noted early on. But certainly it's going to be very helpful to have more time to complete the analyses and with the idea of using all 8 of the TIGA ovens.
Thanks, Bill. Next, we're going to go to Craig. Sorry,
Vicki? Can I just comment as well?
Certainly.
I didn't say this on the atmospheric analysis, but of course the extended mission is very important for understanding the seasonal variations here. We've had this calm period over the summer, and we're expecting to see much more in the way of dust and cloud activity as we go later on in the season. So we're really looking forward to that on the atmospheric science part of the team.
Thanks, Vicki. Next, we're going to go to Craig Kowalt from Aviation Week and Space Technology. Craig?
Yeah, hi. Thanks very much. I don't see the Mika guys there. Are they hiding under the table, or? So could you tell me about the data from the second Mika wet test? Are those data provocative, and if so, why? And for, I guess, Mike there from headquarters, have you at least notified the President's Science Advisor's office that you're looking at what you're going to tell me about you're looking at? I hope.
I don't know what I'm going to tell you you're looking at. We have seen the salts inside of the MECA wet chemistry cells. The 2 cells give a very similar description of the soil chemistry, and they're taken from the surface sample and a sample above ice. We purposely tried not to put ice into MECA since it adds water to the sample, and therefore you would have less of the ingredients that it's able to analyze. There are some signatures in there that have not been interpreted yet, and we are still working on the analysis of those, so it's too early for me to say what else we have in there besides the salts and the alkalinity that we've released. Probably over the next month or 2, we'll be able to understand fully what we're measuring in the MECA cells.
Just as a note, I mean, it's one of these things where the soil is turning out to be different than what was expected. You know, it's alkaline and it has these salts in it. So it's a substance that we're not familiar with, and it's different from what the Mars exploration rovers have found. So not only are we waiting for the MECA results to be analyzed, but also how does that corroborate with the results from TIGA. So there's a lot more work that needs to be done before we have any kind of real conclusion as to what's in the soil.
Next, we're going to going to go to Kate Tobin from CNN. Kate?
Yes, this is Kate. Can you hear me?
We sure can.
Okay, excellent. This is a question, I guess, for Bill Boynton. You indicated that for the sample that is now in the TIGA, take about a week of baking and then 3 to 4 weeks of analysis. Can you talk through a little bit more about that process? How long does it take to get the data down? What happens once it gets on the ground? And could you give us a couple of examples of the types of compounds you think you might see?
Sure, I'd be glad to do that. The standard way we look at the samples is the first day, which is the day that's already been completed. We heat the sample up just a little bit above the melting point of water ice. We heat it up to about 35 degrees Celsius, a little bit warmer than room temperature. And so at that point, we look to see if indeed we find ice based on the melting, and in this case we did. And the other thing we do is we spend about 90 minutes drying out the sample in case there is any water ice in the sample. After we melt it, we want to get rid of the water. So at the end of that first day, we're actually drying the sample. On the second day, we typically will bake out the mass spectrometer, and the reason for that is we may have gotten a lot of water introduced into the mass spectrometer, and water is one of these molecules that tends to stick to different surfaces. So we try to work pretty hard on pumping those molecules out so they don't interfere with subsequent analyses. On the third day, we'll do a ramp where we heat the sample up to about 175 Celsius. The reason there is we expect that there may be some oxidants in the sample. The Viking instrument, for example, wasn't able to find organic molecules, and one of the hypotheses is that there's some strong oxidant in the soil, and so we had always planned on heating it up to temperatures in the order of 175 that might decompose some of the postulated oxidants. After that, we then heat it up to some intermediate temperature. It's kind of a to-be-determined temperature where we might suspect organic molecules to be coming off. And so we look very carefully at that particular temperature that we choose for organic molecules. The day after that, we heat it up to 1,000 degrees Celsius, which is our maximum temperature. And then the day after that, we heat it up to the same temperature to get a baseline to subtract from the previous day. So it's a pretty complex process to go through the entire analyses. And then, of course, once we get the data, we have to kind of split up our time between looking at the data and planning for the next sample and doing all the data reduction. So we're going to be some pretty busy boys and girls for the next few months.
I think we have time for one last question from Todd Halverson from Florida Today.
Thank you very much. I have one and a follow if I could. The first, I think, for Mr. Myers from headquarters. Could you give us a estimate on the cost of extending the mission? And then I have a follow, please.
Yeah, certainly. To extend the mission to the end of the fiscal year, we're putting in something on the order of $2 million, and that should take it through the end of September 30th.
And your follow?
You know, I'm just thinking back to